Hi, my name is Calvin Matthew, and I'm from Plantation, Florida, in the United States. My project is developing a continuous hemodynamics monitor for postoperative cardiac care to prevent decompensated heart failure. This is a clinical syndrome where the heart is unable to pump normal amounts of blood, and it affects 3 million people annually, with the resulting $31 billion in direct medical costs. The big issue is that the symptoms that doctors use to diagnose heart failure, such as changes in weight, occur too late and leave no time for actual treatment. So my project's first engineering goal was to develop a smart sensor to make diagnoses even before symptoms show. I plan to have an implantable sensor wrapped around the pulmonary artery, and this was chosen because literature proves that changes in this artery is one of the earliest signs of heart failure. The implant will then wirelessly send the data it receives to a sensor on the patient's chest, which can display results, trends, and possible diagnoses on the patient's smartphone. To create my sensor, I used electromagnetic simulations and inkjet printing. Once I had my final prototype, I tested the biomechanics of my sensor. When I recreated the pulmonary artery's physiological pressures, which is between 1 and 4 kilopascals, I saw that my sensor's readings were highly sensitive to pressure changes and was able to record changes in hemodynamics. In phase 2 of my project, I decided to show an application of my sensor. I used its real-time data to make the telemetrically adaptable medical devices using voltage-based actuation systems. I tested my final invention on different setups, including a pulsatile pump. I used saline to modulate both normal and abnormal blood circulation, and my final result on these setups was that my sensor was as accurate as clinical standards, with less than 2% error and statistically insignificant ANOVA results. My novel design outperformed the world's most advanced cardiac sensors across industry standard performance metrics. The promising results of my sensor support its application as a compelling and 100 times cheaper, ultra low cost alternative to current heart failure monitoring methods. Thank you so much.